Let's begin, and we're just going to do a quick little note on situations where we change measurements. So what do I mean by that? As in changing the dimensions of a particular shape, how does that affect things like area, perimeter, volume, those kinds of things. So yeah, we just want to see how that might affect those things. So we'll start off with just a basic rectangle. What happens to the perimeter if you change the dimensions, so both the length and the width, by doubling it? So to get started, we'll just need to know what is the original area. So remember, area is length times width, which in this case would be 7 times 5, which is 35 centimeters squared. The original perimeter, we can think of it as we have another 5 and another 7 there. So 2 lengths of 7 plus 2 lengths of 5. 2 times 7 plus 2 times 5, that's going to be 14 plus 10, which is 24 centimeters. So that's the original information given this particular rectangle. So now we want to double those dimensions and then see how does that affect our area and our perimeter. I'm just going to draw a very bad rectangle here. So instead of 7, what's 7 times 2? Well, that's just going to be 14 centimeters. For the width, we're going to do 5 times 2, which is going to be 10 centimeters. Okay, so now what's the area? Well, length times width now in this case is going to be 14 times 10, and that's going to be 140 centimeters squared. Perimeter is going to be 2 times 14 plus 2 times 10, which if we do these calculations, that's going to be 28 plus 20, which is going to be 48 centimeters squared. Okay, so we want to figure out how much did they change by? But not necessarily the quantity amount. So like you could say like, oh, the perimeter increased by 24 centimeters, but the ratio amount. So how many times larger is this value here? Or how many times larger does it get when you double the dimensions? And in this case, what we can see is from the original perimeter to the new perimeter, if you double the dimensions, you double the perimeter, which makes sense because each side length is just doubling. So the overall total of those side lengths should double. One thing to be careful about, though, is when we do the same thing with the area, when we look at the old area and see how much larger did the new area get, it's not actually double. But in fact, if you do the calculations, it'll actually quadruple, as in times 4. And so this is something just to be careful about when we go through these kinds of things. Changing the dimensions will have a different effect on the area than it does on the perimeter. So you can't just say, oh, I added 10 centimeters to the length, the area is going to increase by that amount, because it has this extra multiplying effect in comparison to something like the perimeter. Okay, let's take a look at, that's just some extra space for work, at conversions. So conversions, you'll be asked to convert things from either kilometers to meters to centimeters to millimeters, or the other way around, so starting with millimeters or centimeters to something bigger. So I've just set it in order here. And the idea is basically we have to remember what the conversion is between the two. So just remember there's 1,000 meters in a kilometer. There's 100 centimeters in a meter. There's 10 millimeters in a centimeter. And if we're looking at millimeters to meters, there's 1,000 millimeters in a meter. So what does that mean? Well, what we have here is if we want to convert from one of these bigger ones, so whether it's kilometers to something smaller, we're going to have to multiply the original measurement. So let's say we have 2.5 kilometers and we want to bring that to meters. We're going to have to multiply that by whatever this conversion factor is. So let's say 1,000. And in a sense, that's saying like 1,000 meters per kilometer. So in a sense, we're actually using rates here, but we're using rates to convert things. And that would give you 2,500 or 2,500 meters. So as long as you know that conversion factor, if you're going from the bigger thing, just multiply the bigger thing, as in like the bigger measurement. So whether it's kilometers to something smaller, whether it's meters to something smaller, and multiply it by the conversion factors. And you might have to use multiple. So if you did from kilometers to centimeters, then you'd have to do another like times the 100 centimeters per meter to get it to the next step. All right, what about going from something smaller like centimeters to meters? Let's do that. So if I have 278 centimeters and I want that in meters, what could I do? Well, now you're going to take a look at the conversion factor that involves meters and centimeters. So there's 100 centimeters for every meter. So what we need to do is we need to divide now by that conversion. So we're dividing 100 centimeters per meter, the 278 by that number. And what you're going to get in this particular case is 2.78 meters. So the number is getting smaller, which makes sense because meters cover more land. So you don't need as many of them to cover the same amount as you would centimeters. And that's the idea between converting. Just a very quick recap of those kinds of conversions. All right, so let's make use of those conversions in a question like the one we looked at before. So what if instead we were asked to change the units of that rectangle and we wanted to change it into millimeters? So we can convert it into millimeters. So let's say, what is 7 centimeters in millimeters? So how do we do that? Well, what we're going to do is 7 centimeters is bigger than millimeters, so we're going to have to multiply that 7 by something. So we're going to do 7 centimeters times, let's go back to the table, it's just above you on the page. There's 10 millimeters for every centimeters. So we can say 10 millimeters for every centimeter. And if we do that, 7 times 10 gives you 70 total millimeters. Okay, so I can cross out that first measurement and just rewrite it as 70 millimeters. Let's do the same thing with 5 centimeters into millimeters. You're going to do 5 centimeters times, again, the same conversion factor. So if you're doing multiple side lengths, it gets a little repetitive, but the same kind of calculation. And 5 times 10 will give you 50 millimeters. So cross that out, 50 millimeters there. All right, so now let's find out the perimeter and the area given our new side length. So the perimeter, let's do that down here. Perimeter is nice and simple. We have 2 lengths of 70 in the rectangle. There's 70 down here, 50 across, and 2 lengths of 50. And that would give you 140 plus 100, which gives you 240 millimeters. All right. It's not too bad. And if we look back at the original one, the original measurement you had gotten was 24 centimeters. And this is just 10 times bigger, which makes sense. All right. How about the area? So the area is going to be 50 times 70, which is going to be, if we do that calculation, it'll actually be 3,500 or 3,500 millimeters squared. And if you look at this area with the original one was 35 centimeters squared. So you can see it's actually multiplied by 100 times instead of just 10 times. And that's maybe a little unexpected, but it's because our unit is we in a sense of multiple millimeters squared. So that kind of has a multiplicative effect on the conversions itself. So in total, we have this area and this perimeter in millimeters versus the original centimeters we had. All right, and that's everything for this particular lesson.